We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
G'day, Space Junkies. Welcome to the Space Junk podcast. And today I am joined by Kat Ross, who is zooming in all the way from Western Australia, where apparently they've solved the COVID thing, or near enough, which we have yet to do. So this is very exciting. And Kat is a PhD candidate at the International Centre for Radio Astronomy Research at the Curtin node. Curtin being Curtin University, not the curtains on your window. I often misspell it and always get in trouble. Kat, it is a pleasure to be speaking with you. How are you?
I'm good. Thank you so much for having me. Yeah, it's pretty nice to be calling in from the office. Pretty sad for the rest of the East Coast, but we're doing okay here in Perth.
I am unbelievably envious. It's like,
yeah, I never thought I would.
Behind you, I'm like, oh my God.
Exactly. This lighting that's used to be so harsh and painful is now delightful. Yeah.
You're basking in the neon glow.
Delightful.
I was explaining just before to Kat that this here is a Christmas tree which has little LEDs on it, and because my apartment electrics have not worked for a while now, when the sun goes down and I have to record something, I light myself with this Christmas tree, which like
it's the greatest lighting ever.
Well, it's really fun, but it doesn't have any of the utility of the office lighting that you've got there. So I apologize.
It's a very specific aesthetic.
Yeah, this is a slightly film noir look here, where we've got like the sun coming in here and then like darkness in my apartment. So that's okay. This is what we do. Now, where to begin? Kat, who are you? What do you do?
Well, where to begin answering, I guess that's a pretty big question. I'm a PhD student at the moment at Curtin University. I'm a radio astrophysicist, so I like to study the universe, but I study specifically with radio telescopes. In particular, I study using the MWA, or the Murchison Wide Field Array, and I look at black holes in the centers of distant galaxies. I'm basically trying to determine how these black holes evolve and the role that they play in the galaxy evolution as well. It turns out the initial studies I've done seem to suggest we really know absolutely nothing about them. And they're changing and doing weird things that we never really predicted. So hopefully I will have an answer to that by the end of my PhD.
This is a dangerous question, but how far in are you?
So I'm about 18 months in, which means I have around 18 months to 2 years left. So sort of just testing the waters at the moment, starting to get some results out, but hopefully got some plans for some future projects I'm pretty excited for.
That is fantastic. That's like the golden stage of the PhD. So
that's what I've heard, yes. Gonna try and embrace it while I have it, yeah.
Although I must say that like doing a PhD is still way better than doing just about anything else. So
it's pretty great. It's a nice feeling to be able to just direct your research and you're like, find something cool and you have the freedom to be like, I'm just going to follow that, which is exactly how I got down this track anyway. It was completely different to what I planned, but we found something weird and figured we better follow it up. So here I am. And
what did you plan?
I'd originally planned to look specifically at the supermassive black holes inside of galaxies that were really young. So they're really compact, they're smaller, but we don't know if they're smaller because they haven't yet grown to the size of typical black holes, or have they been confined? Is something forcing them to stay small? And so I was going to try and answer that question of why these particular baby black holes were, in fact, if they were baby or not. But then when I looked at them to see if they were all doing okay, check in and see what was happening, turns out a lot of them were changing. Some of them didn't look like baby black holes anymore. They looked like typical galactic centers. And so all our original thoughts kind of went out the window. We had to follow up and see what was going on. Are these sources actually the sources we think they are, or is something entirely different happening? And that's what I'm hoping to answer.
That is extremely cool. Tell me more about this radio astrophysics thing. How does it work? So, I mean, you're looking at data. I assume you're looking like a wide field array. You've got a lot of different sensors, or a lot of the same sensors across a wide area trying to pick up signals. How does that look when you're actually looking at the data?
complicated, to say the least, very complicated. So the Murchison Wide Field Array is a collection of these dipoles that kind of look like little spiders, and they're in groups of 16 and then spread out across the Australian desert on a maximum distance of about 5 kilometres. So you're essentially working with a telescope the size of 5 kilometres, but just with some holes in it. And that's really typical for radio telescopes, to have these lots of little telescopes spread out that then combine to act as one big telescope. And so the data that we collect is looking at each of those individual mini telescopes and then trying to combine them together to make one big telescope. Eventually, we try and do some really fancy coding stuff that, I'll be honest, it's kind of a black box. I don't entirely understand myself. But ultimately, we then actually get an image. And the reason the MWA is called a wide field array is because when it looks at the sky, it has a really wide field of view. So it can look at roughly a few thousand galaxies at the same time. So that's why it's really fantastic to do these surveys with, because we can survey the whole sky quite quickly and then come back and do it again and see if things have changed. So it's a pretty unique instrument.
That's awesome. And how has the field changed over time? Have we been getting bigger? Well, as in, like, in terms of these wide field arrays, are we getting wider over time in terms of like the, I guess, mathematics we're able to use to combine all of these different sources of data? Or like, do you think we're going to keep spreading these wide fields arrays out? Or are we doing the same thing that we were doing 50 years ago? How does it look when you look historically in this field?
It's difficult because, yeah, we are building bigger telescopes and connecting them over a wider range. In fact, you may have heard recently, about a year ago, the Event Horizon Telescope produced an image of a black hole. And that telescope is essentially the size of the Earth. So it's spread out telescopes across the size of the Earth. So we've definitely gotten bigger in that sense. But we're also focusing on having smaller detail as well. So having a really compact array that's not really spread out that much can really help you look at diffuse things like a cosmic web that we think is just the structure of the universe and combining all the galaxies and clusters of galaxies together. But you can't see that when you have a really big spread out array. You really need to have a compact array to see that. So yeah, things are getting bigger and better, but we also know that different science cases need different telescopes. So realistically, we actually build a lot of different types of telescopes to really hone into different areas of science. I personally like ones that are quite spread out and that have a really wide field of view, but that's for my own science case, yeah.
Right. Now, with the black holes you're looking at, what are you trying to figure out about them?
So these black holes in particular, they're known as active galactic nuclei. So they're right in the center of these distant galaxies. And they're active because as dust and matter kind of falls into them, they eject these electrons at opposite angles into these really, really high energy electrons. And they kind of form these jets coming from the black hole. But these jets then interact with the surrounding medium and they create these big, like, mushroom clouds, essentially, that interact with the surrounding environment. So you have this really dense core in the center, these two long lines coming out from opposite ends, and then these big, fluffy, waffly cloud things. That's essentially what I'm looking at. But these ones in particular, they're very large. I mean, we call them baby black holes, but they're still like 30,000 light years across. And the telescopes that I'm using, we're really probing the fluffy cloud region, which means we don't really expect things to change that much unless we're waiting the full time it takes for the light to reach out to that fluffy region, which is around 30,000 years. So in the scale of a PhD, which is generally about 3 years, you're expecting to see none of that. It's far too short a time scale. And that's what I did originally, was just meant to follow them up, make sure everyone looks good, everything's fine. Except I came back and they were all changing. Things were doing weird stuff all over the place. They were getting brighter, dimmer. They were changing their shapes. So we kind of figured they couldn't do anything on the timescale of about a year. And then when I went to check to make sure, that was just blown out the window. So now we're just trying to answer what essentially is going on, because we have no idea, realistically. It's such a mystery. Yeah.
How did you get into all of this radio astronomy, radio astrophysics stuff? Where did you, I don't know, where did you begin? Let's go back. Let's go way back to not baby black hole, but baby Kat Ross.
Baby Kat Ross.
Baby Kat Ross. Were you just like always really into physics?
I don't think I knew I was always into physics, but when I look back now, it kind of seems like, yeah, you were always going to become an astronomer. That was always going to happen.
Right.
As a kid, my family used to go out into the street and we look up at the sky and watch the International Space Station go overhead, which I thought was just beyond cool. That's like a man-made thing that we put up into the sky and it's just orbiting around all the time. And then my parents told me that people live there constantly. And baby Kat basically couldn't see anything other than a flying toilet, because if people live up there, then they also have to poop up there. And so to this day, my family will still cover our heads to stop flying space poop from falling on us from the International Space Station. So there you go. I think that was probably the start of it.
And did you, when you went through high school and stuff, were you doing science subjects? What other subjects did you do?
Yeah, I loved science. That was definitely always what I wanted to do, but I didn't know what area of science. So I did biology, chemistry, physics, and maths in high school. Much to some teachers' dismay, they kept trying to convince me to do history or textiles, and I was like, no, it's not science, I'm not interested. So focused just on science, but it was really only in year 12, I went to a science camp called the National Youth Science Forum, or NYSF, where I actually came to Perth and worked with a specific physics group, and we did some really cool experiments and got to see a lot of laboratories, talk to experimentalists and all these experts in the field. And that was kind of the moment when I was like, this is it. These people get to do this for a living. Imagine being able to just come in and explore the universe for a job. Like, that's pretty one of a kind. So after the science camp, I decided I was actually going to do my PhD in radio astronomy after I came to ICRA, the place I'm working at now. And I saw it. I was like, that's for me. And here I am, a full almost decade later, but came back to do exactly what I expected. I definitely took some detours along the way, but ended up here on the same. Yeah.
What were the detours?
I thought for a while I wanted to do quantum mechanics, and I think it was really exciting to learn about just how things don't work, essentially, and we don't really know what's going on. But then the draw of astronomy just always pulled me back. For my undergraduate in honours, I did some work with optical telescopes, but much like in radio astronomy, where they have lots of different little telescopes and they join up to make one big telescope, I worked with an instrument that essentially got one big optical telescope and cut it up into lots of little ones. So it was a really similar technique to the radio astronomy, but used on an optical telescope. And so I used that to try and study the dust surrounding a star. I spent a year studying a single star, and I concluded it was very weird. And I also concluded that stars stuff was not for me. I wanted to work on bigger and better things. So I moved to galaxies, and I moved to thousands of galaxies rather than one individual star. Yes, kind of flipped completely to the other side.
Now, if you are following along at home with this interview and you think, I'm just going to go and Google this Kat Ross character and see what else is out there, find some more galaxy stuff, you will find this Kat Ross, but you will more likely find a Kat Ross who writes sort of like a steampunk historical fantasy fiction thing, who used to be a journalist at the UN. And that Kat Ross seems absolutely awesome as well, but is not this Kat Ross.
What a badass.
So just a warning there. But Kat, what are your hobbies, if not writing fantasy fiction?
I mean, I wish that was a hobby. I'm unfortunately not a great writer when it comes to anything outside of science, I think. So
it's all right,
my
you can use dot points.
Exactly. Yeah. Give me a PowerPoint any day. I think most of my hobbies, I'm a big fan of plants and gardening. My mom is a gardener, and she always tried as a kid to get us involved in plants and love being in the garden. And it was always like, no, Mom, I'm not interested. And then when I moved out, it was like, oh, I need plants. But I'm not very good at it. I think my learning is just, if it doesn't die, then it must be good. So I've had, there's quite a plant graveyard in my history, but I now have lots of happy plants, and I'm conducting a few experiments with them because I'm ever the scientist. So I have a couple of ferns, and I read online that if you give black tea to ferns, cool down, not boiling hot tea, then it acts as like a fertilizer, except that all the people that were saying it worked for them had a sample size of 1, and it was just that their plant was dying, and then they gave it tea and it was no longer dying. So I kind of figured, is that just because you're giving it tea, or is it because you're just giving it something and you were giving it nothing before? So I now am doing an experiment where I have 2 ferns. One gets just water, one gets tea and water, to see if they grow differently. And it was an interesting experiment, but evolved essentially to just more recognition of my mental state at the time, because they don't like to dry out for even a second. So if you're working too hard and you forget about them for 2 days, then they're, how dare you, I'm dead now. So they're on a slow recovery journey at the moment.
Right. I think, well, my mum used to always put the tea leaves on the roses in the garden. So
There you go.
there you go. I mean, she swore by it. She said tea leaves were good for plants. I don't know.
I've not seen anything negative about it. So at the very most, it maybe just doesn't do as much as people think, at the very least, I guess. But at the most, helpful, amazing.
Yeah, very much so. Now, I'm terrible with plants. I kill them all the time. And I remember distinctly in year 1 at school, we did a unit on plants, and we learned that plants had to have soil and sunlight and water, the 3 things. And we did an experiment where we took some plants, and then we had one that we didn't water. We had one that we put a box over it so it didn't get sunlight. We had one that we took it out of soil and put it in sand instead. And then we had our healthy plant, and, you know, we went through this process and the plants died. Of course they died. And this was, you know, a learning experience. But to this day, I have not been able to remember that when faced with a plant of my own. And every time I forget, and then it'll be dying and I'll be like, oh,
why are you dying? Oh, I haven't watered you for 3 weeks. Yeah.
So I'll take it into the bathroom, because I'll be like, that way it's next to the water. I'll remember to water it every time I like go have a shower. And then it dies because I've forgotten to give it sunlight. And I'm like, oh my God, sunlight. Anyway, I don't know what the moral of this is, but I think it's that plants are difficult. And I wouldn't consider myself like an incapable sort of person or even forgetful, but it's just,
plants
isn't there.
Fun. I found, this is what made me be okay with the amount of plants that I was killing. So my mum said, if you get a plant and it dies, essentially just think of all the plants that you get as a bunch of flowers. So the flowers are always going to die. That's inevitable. But you try and make them last for as long as possible, and you still get joy from a bunch of flowers, despite the fact that they then die. And so it can be the same with the plant. You can have it, you can still get joy from it, and then it can die. And you're like, well, I enjoyed it while I had it. I did kill it, that's sad, but I still had fun while it was alive. And
that's
has
very
been
true.
my approach since then.
That's a great approach. Maybe I need to try this again. Maybe as we head into our next round of lockdowns, I can, you know, have a plant and try and keep it alive.
Actually keep it alive, yeah.
Maybe, I don't know. Now, Kat has TikTok, and I know TikTok's been in the news recently for stealing data and stuff. I'm not going to comment on all of that. All I'll say is it's a lot of fun. And and I love watching Kat's videos. She has my favorite video of all time across all of TikTok is a video of Kat watering her plants with this like groovy little watering can while I don't know what's the word, miming along or
like lip syncing,
like doing karaoke but without the sound, to Julia Gillard's misogyny speech, and just watering these plants with such sass, and it's incredible. Really good. Go look it up. If I could figure out a way of downloading it, I would cut it into this video now, but this is that happen. But tell me more. Why, how, I love it, but what led you to decide to make a video watering plants while lip syncing to the misogyny speech?
I mean, firstly, big fan of the misogyny speech. It was not hard to learn the lyrics to it because I had basically memorized it from watching it countless times anyway. So there wasn't really too much work involved in that side of it. But I think also just, everything that's going on, it's easy to get caught up in just constant negative headlines. And so it was hard for me just to be doing something fun that I enjoy. Firstly, I'm watering my plants, good stuff for the plants, but also yeah, it was just fun to make the video. And I figured if it's fun for me to make the video, it must be fun for other people to watch it. And clearly you agree, so thank goodness, not wasted time. But yeah, it was just really good fun. And I think that was generally my approach for TikTok. I thought of it at first, like, I'll have it as another science platform where I can present some of the stuff that I'm doing as a science communicator and as a PhD researcher. But then eventually I'm just going to have this for fun. And it's been good. I enjoy it.
Would you consider yourself a feminist?
Oh, definitely. Yes, absolutely.
I thought so. One doesn't want to assume these things.
It's weird. I think that the word feminist gets such a bad rap. And there are plenty of people that would probably actually sort of think of themselves as a feminist, but not actually the name feminist. But I think that that's come from a place of internalized misogyny and from a patriarchal society that tries to discredit the overall movement by discrediting the actual title of the movement. And yeah, I have absolutely no shame in calling myself a feminist and working towards feminist goals and ideals. And I think that it's sad to see people want to do those things but not call themselves a feminist. Yeah. Difficult.
It's interesting how the meaning of these terms changes over time, and there's a lot of sort of value ladenness in the wording as well. I think with the word feminist, I mean, I feel much the same way. I'm like, yes, of course I'm a feminist.
Yeah.
Why would I not be a feminist?
Why would I not be?
But it is interesting, particularly with older generations. There's and even like younger generations. I don't know. There's just something about the word that. I think for some people brings up negative things. And it's really interesting to see over time. Well, as someone who does a lot of like sociology of science and kind of all of these philosophy things, it's a classic case of a what we might call a boundary object.
Yeah.
It's this thing that gets sort of pushed from all sides with different ideologies and so on. And this word can change in its meaning to different groups depending on the circumstances. It isn't really its own thing, but yeah, it is so fascinating. If I think back to Julia Gillard giving that speech and where we were then, it's really interesting the way that over time, I think, I'd like to think that people look back on that speech as being like really good, and that maybe it's even more popular now than it was then. I'm not sure.
I hope so. Yeah, I think it seems to have gotten a bit of like a spike in talking when, we started having Tony Abbott being back in the media and everyone was like, oh, remember that time Julia Gillard absolutely roasted him? Hilarious. So I think it comes in like ebbs and flows. But even at the time, I mean, I think I had a very typical journey to feminism that in high school, I didn't consider myself a feminist because, we have the right to vote. What more do we need? And it really just comes from a place of ignorance that you don't realize quite how intrinsic a lot of the sexism is and how just folded into everything that we do this misogyny is. And so I remember watching it being like, oh yeah, it's great because Tony Abbott's getting roasted and that's hilarious. But as I sort of aged and I learned more and I matured and I understood what feminism actually is, I kind of went back to it and realized like how iconic of a moment it was that we finally had someone who was a female in power and actually just taking a stand to be like, you know what, I'm sick of the way that you treat me, like that's enough, and just taking up space. Like that's such a hard thing for women to do so frequently, and that we had someone who was in power of the country, who was leading our country, say, I'm taking up the space that I deserve and you are treating me poorly and that's not okay. I think that was a really iconic moment. And it very much having that mindset and realizing that there are moments like that through history was very much inspirational to me and motivating to me as well in things that I do. And it's sort of, things may ebb and flow, but you still have those powerful moments that come and you can really work forward from there.
Yeah, the taking up space thing is a big one. It's interesting that often, someone said to me once that the internalized view is that the correct size for a woman to be is nothing. Like like you sort of always just want to not be there somehow.
Yes.
And
yeah.
yeah, it's really interesting, and there's a lot of research that's been done into this, and it really affects the way that people in society operate. It's even stuff like walking down the street. It really.
I was just about to say, women are always the ones that move aside. If you're on a collision path with people, women are typically the ones to be like, oh, I'm in the way, and move aside and let a man walk past. And I, since learning that, was like, I do that. I'm not okay with that. I'm not okay with always being the one to move aside, or always being aware where everyone is and spending that mental energy constantly looking at, should I move aside? I'll move aside. I have to move then. And men don't think of that in the same way. So I made a really conscious decision that no, you stand your stride. If you're, walking to the left, they can move aside for you. And since making that decision, it is shocking the amount of times people just walk into you, hit your shoulders, they don't say sorry, there's just turning off like, excuse me? And you're like, I've just been walking in a straight line on the left of the pathway. You're just outraged that I didn't move out of the way for you. It's really interesting how much of a difference it actually makes for you to just stand your ground in such a trivial thing as walking down the street. It's very odd. Yeah.
The only time that changed, because I also read that and was like, maybe I'll like experiment with this. And yeah, totally, like all of these older men kept like walking into me and then being like, what?
How dare you? It's your fault when they walk into you every time. And you're like,
but the only time it changed was at the very beginning of this COVID outbreak in Sydney. There was a period of time where we weren't really sure how serious it was, and where older people started being really nervous about being around younger people. I don't know if this happened.
And you get your 1.5 meter berth as you're walking. Yeah.
And so there was this period of time in which I was able to just walk, and all of these older gentlemen normally would just sort of hop out of my way as I walked, looking at me as if I might have COVID, and it was lovely. But
who knew
obviously
the pandemic would help feminists walk down the street?
That's right. Let's talk about women in STEM.
Amazing.
Given that we've sort of transitioned around feminism, now we're coming back towards practical feminism. Yes. Women in STEM, it's something that you are quite passionate about.
Very much so, yes.
Tell me more.
So I think the same sort of thing. It was very much a journey at first that I don't think it was really that much of an issue. And, I got into science, and it doesn't matter if there's less women in there. It means that, people will want to hire me because I'm a woman. So it must be great. And essentially that's not at all the case. That's not how that works at all. And I found that the more I learned about women in STEM and the difficulties surrounding that, the more I realized that I'm really just, there's a lot of issues that need to be worked on. So it was actually after my honours, I went to a talk by Professor Athene Donald, and she gave a talk about specifically women in STEM and whether those numbers are increasing or decreasing, and what are some of the things that we're working towards. And she's head of the Athena Swan program in the UK. And she mentioned just kind of like a throwaway term of just imposter syndrome, and just kind of moved on. And I was like, what on earth is that? And I started doing a bit more research. And for those who may not know, imposter syndrome is this feeling that you are an imposter in what you're doing, that you really don't belong there, and that eventually someone's going to find out and kick you out of the program or wherever you are. And a lot of the side effects of imposter syndrome are things like you attribute any success you have to an external factor. So whenever you do well, you can't actually appreciate that you've done well. It's usually, I was lucky, I had help, this happened by chance, stuff like that. Rather than, no, I actually worked hard and I produced something that was good. But then when things go badly, you're much more vulnerable to taking that on board and not being able to work through it. So I kind of started researching about imposter syndrome, and it just was like a light bulb moment for me of just all these struggles that I've been going through. I assumed was because I was not good at science and I didn't belong to be here. I'm not as good as everyone else here. They're all confident. They know what they're doing. It didn't make sense with any of the marks that I was getting in my undergraduate. It didn't make sense when I would talk in class or anything like that. But again, you don't see those positive sides and you only see the negative. So at that stage, I kind of took the initiative to be like, I'm really going to research this a lot more, and started researching about the effects of having a patriarchal society to women in STEM specifically. And it turns out it's just rampant in academia. Things like men are seen as more hireable, more competent, and often more career mentoring, and $5,000 more for a starting salary than their identical female counterparts. Resumes that are exactly the same, but just a different name was the only clarifying factor there, and men were always seen as better. And it's just things that are out of your control, being a woman in STEM, in order to progress and in order to have a career. So it sort of burned a fire in me to really sort of do what I can to see that changed. And the more we talk about it and the more we have these conversations, yes, it's going to make us uncomfortable, but unless we're uncomfortable for a bit, we're not going to see anything changed. So I've since then really been working towards making sure we have these conversations as much as possible.
Yeah, imposter syndrome is just massive. And I mean, I find it, I came across the concept similarly and was like, oh, that makes sense.
I see.
Because I don't know, I guess like even in my field, I suppose that first off, there aren't that many people, but even beyond that, even in my department at the university, I'm the only person working on the stuff I'm working on for my PhD. So there's no one else in my department who does anything to do with space or Antarctica.
Right.
So it's really all very self-directed. And as a result, it's this weird thing of, I don't know, it's like, it's this very high stakes game where it's like, if it goes well, that's fantastic. But if something goes wrong, it's always my fault. And
yes,
it's so interesting the way that it impacts you. And I didn't even realize this, but I was talking to someone recently who was giving me some mentoring through the UN Space for Women program, which is all very exciting.
Oh, yeah.
Yeah.
Cool.
And anyway, I was talking to her and she was like, so what are you going to do after your PhD? And I was like, I don't know. And she's like, well, like, what about academia? And I was like, well, I don't know. And she's like, why don't you know? And I was like, I don't know if I'm good enough for academia. Like, I'm not sure. I've no idea whether that's a cutoff. And she was like, I can't believe that you're saying this. And I was like, I can't believe I'm saying this either. But I guess in my head, and I hadn't even realized because, you know, usually things go okay, but I was just like, I hadn't even realized that there was this imaginary hurdle in my head for what you had to be to like pursue a career in academia. Yeah. And
it's
I had
entirely
just discounted
self-designed.
it. Yeah, because I was like, actually haven't even attributed what qualities that would be. I just was like, no, that's
it's not me. Not that one. There's a hurdle here and it's not me.
Yeah, and it was really interesting. And I had to like sit back and reconsider. And then as I was sitting back and reconsidering, I heard a podcast that you were interviewed in where you were talking about the #IncludeHer campaign that you're doing. And you mentioned that there are very few, and we'll go on to talk about this more, women in STEM who are mentioned in textbooks.
Yeah.
And I realized that not only was it my science textbooks that didn't have anyone who sounded like me, looked like me, had a name like Annie, which like, honestly, people keep asking me if it's a nickname. And I'm like, no, it's just my name.
No, this is my name.
Not only that, but also like all of my geography textbooks, history textbooks, every textbook, because I don't even know if my field counts as STEM. It depends. You know what? I'm really cynical, Kat. I think my field gets counted as STEM when they need to up the numbers of women in STEM for the university.
So, and then discount it otherwise.
They discount it otherwise.
But it's only STEM when we need it.
Exactly. So when they need to like have a bouncy woman to like wheel out on stage to talk to like new HSC people, they're like, woman in STEM, it's Annie. And I'm like, but am I? Anyway, that's all very cynical. But yes, textbooks, like the whole thing, it was insane to me. I was like, how could I have missed this? That of course I don't see myself in academia because there's no one who looks like me. Even though my supervisor is a woman, I was like, but that's one person. It's just there's something really deep. Tell me more. science, include her STEM textbooks. What's the deal?
Yeah. I mean, it essentially came about for the exact reason you said, that it was just, I kind of learned of it. Someone pointed out to me, I was actually doing some work at the time at the Sydney University Physics Education Research Group, or the super group. And we were going through the incoming physics syllabus dot point by dot point to introduce new resources and some fancy things for teachers. And someone pointed out that Marie Curie, who invented radioactivity, won a Nobel Prize in physics and chemistry, basically she just was not mentioned anywhere in the radioactivity section, which I was kind of like, but you can't teach it without her. Like, how is she not included? And it got me thinking, and to be fair, I'd been working on this syllabus for about a year by the time we noticed this. So it does kind of hit you, you learn of it, and you're like, how did I not notice this? How did it go so long without us figuring this out? And so I figured, let's go through and see who else may be missing. And I went through the physics syllabus and just found there was ample men just mentioned everywhere, in context both of like so-and-so's equation or this relation, but also just specifically of the scientists. There's so much in there looking about how scientists contributed to science. And so you look at these scientists and you learn like, wow, they've contributed, they've done all this stuff, but it's only ever men. There's no women mentioned in the entire physics syllabus, not one. And it turns out across New South Wales, it's pretty similar. Across New South Wales for all the STEM courses, there's basically no women, but there's so many men mentioned in a range of contexts. And it was very disheartening to see. Kind of like, I get that this can come from a point of unconscious bias where you don't realize that they're not there. But now we know they're not there. Like I've pointed it out. We should really be doing something about it. And this is where the Include Her campaign started. And it's turned into a full national movement. I now have about a dozen volunteers. We're going through each course for each state as well, and comparing them, seeing how many women are mentioned, how many men are mentioned, but also looking at the places where we can include women without really changing too much. Because it seems, and this is what really surprises me, a lot of the science that women have done is already in the syllabus. It's just not being attributed to the women. It seems that we really only care about the scientist when that scientist is a man. And that's fundamentally wrong and inconsistent. You know, we're only presenting half of the story, and it's just inaccurate. So some of the work we're doing is really just saying, where can we include women where they really already should be mentioned, but they're not. Yeah.
So Kat, is it just that they have taken out all of the scientists and it's a focus on the actual science? Or is there a mismatch? I mean, how many women are we talking? How many men are we talking? What's the ratio at the moment?
Yeah, it's a little bit of both. So in some states like Victoria, they really tried to avoid mentioning any scientist whatsoever. And then in New South Wales, there's a real focus on the development of science and the history of science as well. And they use that development of knowledge to really build up the actual understanding of physics as well. So there's a lot of background of scientists involved with that. But in New South Wales, across the science courses, they mention around 80 men over 100 times, well and truly, and they only mention 4 women, which is Marie Curie. She is mentioned, not in chemistry or physics, but she's mentioned in investigating science. And they also mentioned Barbara McClintock. She also won a Nobel Prize for her work in genetics, and she's mentioned in science extension. The other 2 women that are mentioned are Edna Krabappel and Maggie Simpson, the cartoon characters. So there are just as many cartoon characters as there are women in STEM. Okay. And then there's just a buttload of men.
Okay, and if I'm putting on my skeptical older white man hat right now and they say, well, yes, but there were more men in science historically, and that's maybe because of the patriarchy, but it might also just be true. What do we say to that?
Well, I mean, that was one of the biggest criticisms that I got. You know, it's not their fault. Women just haven't done anything through history, and things are named after men and blah, 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 blah. And I mean, firstly, the named after men, well, 50% of the mentions in physics alone specifically looks at the scientist, not just the science. So that's already out the window. We care about the scientists, not just the name of something they did. In terms of women just weren't involved, well, it turns out that's also just false. So if you go across the New South our syllabus and you simply attribute the name of the woman to the science that's already there, you can increase the representation from about 1% up to almost 40%. So it's very easy to be including them. We just have seemed to overlook them due to an unconscious bias. But names like Einstein, Newton, and Maxwell, they're very much included everywhere because we all know them, we all grew up and we were through this system that really highlights those male scientists and diminishes the work of women. So it comes from that place where we prioritize men and just seem to overlook and ignore women. But the science that they do has really contributed to science overall. So we still learn of that incredible science. We just don't attribute it to the women who did it because, again, we overlook them. Yeah.
This is something that I always break the brains of our incoming undergrad students with in the School of History and Philosophy of Science, which is where I spend my time. And we really destroy a lot of their preconceptions by pointing out that history is an active process that is written by people with particular interests in mind. So,
exactly,
there's no such thing as an unbiased, completely objective history of anything. But when we look at the history of science, especially, a lot of the students come in with this preconceived idea of, well, it was in my textbook, therefore that is the truth. And a lot of what we do is we problematize that and we say, well, maybe something on Wernher von Braun, for example, in your textbook would have emphasized the science and de-emphasized the Nazi aspects. And that's because that's the way that Western science has rationalized our involvement with that whole thing, because Cold War, blah, blah, blah. So you're trying to basically provide all of the other bits of the story so that you can see it in context and understand not just that, it's not that the history is wrong, it's that a particular narrative has been told for a particular purpose so that we can conclude things. And if we change anything about that narrative, it will change the conclusion. And that's just how it works. And I don't know, what do you think about that? I mean, do you think that that with these science textbooks and with the syllabus, that it's trying to tell a story that is more objective, or what do you think? What's going on?
Yeah, and I think it varies from state to state whether they want to do a narrative and tell the story and develop the knowledge that way, or whether they're really just focused, ignore the narrative, ignore the history, here's the science. I don't think either is better or worse. I think having that contextual background can really help students grasp complex things and really understand it. And the narrative is part of that. Having a narrative can really help students understand and retain information. But I think when you know that the narrative you're telling is biased, then you should be addressing that. And when we only tell narratives that are of men, we're basically normalizing that scientists are only men. And we're telling these high school students, especially the young women in STEM who are aspiring to careers in STEM, we're telling them essentially that your career ends at high school. There's nothing for you after that, which is flat out wrong. But we ignore the women through history, and we also don't provide enough visibility to the women in STEM that we have today to really change that narrative at all. And whether this comes from a place that was deliberate to only have a narrative of men, or whether it came from an unconscious place, doesn't really matter. It's the narrative that we're telling, and it's an inaccurate narrative that actively harms a group of people. So it's something that is fundamentally broken about the way that we're presenting science to students. And that's why I think it's something we should really be working on fixing.
Okay, Ruby Payne-Scott was a radio astronomer. Tell us more about Ruby Payne-Scott, because of all of the female scientists who you would expect to see in a textbook, she's way up there on my list. What do we know about this person?
Well, I mean, that's the thing, is the more I learn about her, the more it seems like she should be in a textbook. But I mean, I went through the system where we didn't have role models. I didn't know anything about female scientists. And so my female role model was a science fiction character. It was Captain Kathryn Janeway from Star Trek Voyager. Total badass, love it, so good. Helped that she had the same name as me. But I mean, as I kind of realized that, this syllabus and these textbooks were lacking the female role models, I started to look into who could be included. And that's actually where I found Ruby Payne-Scott. And she was a radio astronomer from Australia. So, we love her. homebrew person. You know, we love an Australian. And she really just pioneered radio astronomy in Australia. And it turns out Australia is really at the forefront of radio astronomy as it is. And when it was this new field and we just discovered what it was, she was there helping us develop telescopes, trying to figure out what we were seeing. And that work that she did really helped solidify Australia as a front runner in radio astronomy. She was also doing work on things like understanding the sun, and she discovered 3 out of the 5 solar bursts as these radio bursts that they were seeing, and attributed them to the sun. They were all slightly different, but she was the one who discovered that. She did all of this work, but her career was only 7 years, because she actually worked for the CSIRO at a time when there was a law that when a woman gets married, she has to then leave her job and become a good housewife. So she actually lied about being married for a while, but after it was discovered, she was asked to leave. And so imagine all the work that could have happened had she stayed in her career. And I think she's also quite a badass as well, which I quite like. She used to wear shorts on field, which a woman wearing shorts. It's not spoken of.
Outrageous.
So she used to wear shorts, and people would comment on it, and she'd be like, well, I mean, I'm climbing ladders all day, I'm doing all this stuff, like what skirt am I going to wear that's going to be able to do that? So yeah, I think she was just a bit of a badass. And when you learn of women like this through history, it's kind of just like, it clicked for me that Ruby was just this amazing role model that you can aspire to do all this amazing research, even if your career is short, but you can really make such an impact and lead a country in this new field. So she's now absolutely one of my major role models. And the fact that Australia is such a forefront in a front runner in radio astronomy, and we learn so much about astronomy in high school, she should really be included. We should be highlighting this and, you know, celebrating our own scientists. But alas, she's not there, but she's definitely someone I'm working to hopefully get included.
Kat, I have to ask you, one of the things that is awkward for me when it comes to talking about women in science, and I want to know your take on this, is I worry that we focus on women in science and therefore do not focus on sexism in science. Now, this is a weird disjunction, and I really want your take on it. But occasionally, like as someone who works in sociology and history and philosophy of science, I'm always looking at things from one step back. And occasionally I worry, like, okay, so let's say we got Ruby Payne-Scott and we put her in the syllabus as the person who was at the forefront of radio astronomy for Australia and the world. We put her where she's meant to be. Mm-hmm. But what if that's where we stop and we say, okay, now we have a woman in science, now we have representation. Hooray. We actually ignore the whole story of why she wasn't there in the first place, and the entrenched systemic sexism and racism in science. I mean, a lot of the history stuff we cover in the subject I teach is around experimentation that was done in Australia on Australia's Indigenous people, you know, completely unethical. There's a lot of stuff historically that's been done in science and continues to be done that is at its core racist and sexist and homophobic and et cetera, et cetera, et cetera. And so just having representation, I feel sometimes doesn't address it. And I worry about this, and every time I'm asked to speak at anything is sort of like, here's a woman in STEM. I feel that thing where I'm like, am I expected to smile and pretend like it's all fine because I exist? And it's better than it was. And I'm not saying that we shouldn't celebrate women in science, but representation isn't a solution necessarily. Yeah. What do you feel about this?
No, I completely agree. And I mean, putting the names of women in the syllabus and in the textbooks is kind of like slapping a Band-Aid on a giant leak. It's not fixing the problem. The reason I'm fighting so hard for it is first and foremost, we know that what we're doing is currently broken. So to do nothing and to continue doing that is bad science. When we continue doing this and expect a different result, that's just silly. So we have to do at least something. And this is a nice, easy first step. I agree. It is not solving the problem. It is just really just bare minimum, little effort, but I do think that it would make a huge improvement on normalizing women as scientists. But as you say, then it's ignoring the problem of why they were even there in the first place. And this is one of the things that I'm really working on with New South Wales and Australia, is to not just slap the women in there and be like, job done, but actually create an entire new curriculum that integrates women and integrates the history of science within that, of why women aren't introduced in the same way and why things aren't named after women. Having specific content where students have to go out and research for themselves and learn why these things happened and where it comes from. Is it based on the fact that women are intrinsically worse? Plot twist. No, it's not. It turns out it's because of these entrenched biases, like you say. And we need to have those discussions, and we need to make sure that everyone's aware of it. I hate the idea that I got through my entire undergraduate without even knowing about these things. And I am a woman in STEM. It took me that long to learn that that was a thing. I think that that's just awful. People should be learning these things as a part of science. And so, yeah, I think having the representation is absolutely important, and we should not be dismissing it. But it's not the be all and end all. It's not going to solve every problem. But I think that change is really only going to happen if we can all do our bit where we can and do the change where we can. And this is one way that's really simple, easy thing that we can just do immediately and work towards addressing it on a larger scale. It's by no means just going to fix feminism and be like, job done, tick, we don't need feminism anymore. Like, I wish, but sadly no. But I mean, yeah, what we have is fundamentally broken. To not do anything is wrong. It needs to be fixed on some level, and then used as a broader approach on attacking the problem at whole. Yeah.
This has been fantastic. I feel like I should let you go back to poking around in black holes. But if people want to get involved in your campaign, and if they want to follow you, find you online, watch your videos where you water plants, what do they do? Where should they go?
So you can follow me on Twitter at Astro_Kat Ross, or Instagram, Astro.Kat Ross. But recently we've also got the movement itself has its own social media. So please follow IncludeHerSTEM on Twitter and Instagram. Or if you want to get in contact with me, feel free to email myself or the movement at IncludeHerMovement@gmail.com. And we can talk about getting involved. First and foremost, though, if you are outraged by the fact that there are no women, then please, please, please head on to change.org/includeher and sign our petition. The more names that we can get on that, the better. It really shows that we as a country and we as a society want to see it changed.
Okay, you heard it here. Head to change.org, sign the petition, follow Kat Ross at all of the various junctures where you can find her, and also get on IncludeHer.STEM or IncludeHer_STEM for lots of updates and a really interesting conversation that I can personally recommend getting involved in.
Thank you.
This has been lovely. Thank you.
Thank you so much for having me. It was a really lovely chat.
No worries.
Even if virtually.
Yeah, it's all right. I'll be there sneezing on you before you know it.
I can't wait.
See you. You've been listening to the Space Junk Podcast. My name is Annie Hanma, and you can find me on Twitter and Instagram as @AnnieHandma. If you'd like to get in contact, please send an email to thespacejunkpod@gmail.com. And to support this podcast, go to www.patreon.com/thespacejunkpod.